Hi guys, this is the video for module 14.1 and 14.2. This module kind of picks up right where Math 1 left off, and up at the top of the page here you'll see some key vocabulary. First of all, we have complementary, supplementary, congruent, and transversal. Complementary meaning that the angles will add up to 90 degrees, kind of the big thing there, and supplementary meaning that they will add up to 180. That can be kind of tricky to remember which is which, but it's very important that you know the difference. Congruent, meaning that they are the same or equal. Wow, that was not good. Let's try that again. And there we go. And then lastly, a transversal is a line that intersects two different lines at two different points, which you should already be familiar with a little bit, but we'll get into more of what that looks like in just a second. And then we have a bunch of different angle relationships. So you have all of those listed there: a linear pair, vertical angles, same side interior, same side exterior, alternate interior, alternate exterior, and corresponding angles. Now, hopefully that shouldn't be anything new. All of those you should be familiar with. The biggest ones to first of all recognize are linear pairs and vertical angles are just made by two lines. That's all you need in order to make those. The other ones, you need these parallel lines, similar to the diagram here, kind of at the bottom of the page. And so if you notice, okay, I have a diagram here, and the directions say, using the diagram, list all pairs of angles that are, and then all of the different types of relationships. So what I would like you to do right now is go ahead and pause the video, and while it's paused, go ahead and see if you can fill out as many of those as you can. Then continue to play it. I'm going to continue in just a moment and fill those out for you so you can check your work to see how you did. But go ahead and pause that video right now. I'll give you about 2 seconds to do that. Okay, so the linear pairs that we have angles 1 and angle 2, angles 3 and 4, angles 5 and 6, angles 7 and 8. And then there are actually even more of them. You could have had angles 1 and 4, 2 and 3, 5 and 8, and 6 and 7, kind of that direction. Any of those are fine. If you didn't label all 8 of them, that's okay. But just to know that it can go kind of either direction there. Usually horizontally, it'll be easier to see. Then we had vertical angles. So let's get rid of some of that. Vertical angles, right, means they have to be on top of each other when we have intersecting lines. So in this case, that's going to be angles 1 and 3, and angles 2 and angle 4, angles 5 and 7, and angle 6 and angle 8. Okay, a vertical angle would be something like that, okay, 1 and 3, where they are kind of stacked on top of each other at a particular intersection. Then we have same side interior angles. Same side interior are on the same side of our transversal. Here's our transversal right here, line T that cuts through both of those. So they have to be on the same side of that. And on the interior, the inside of our two parallel lines. So for example, that would be angles 4 and 5 and angles 3 and 6. So angles 4 and 5 and angles 3 and 6. Then we have same side exterior angles very similarly. Again, they have to be on the same side of the transversal, but now on the outside of our parallel lines. So that's going to be, like, for example, angles 1 and 8, angle 1 and angle 8, as well as angles 2 and 7. alternate interior angles. When you see the word alternate, you need to remember to think opposite. And so those are going to be on opposite sides of the transversal. And again, depending on if it's interior or exterior, on the inside or outside of our parallel lines. So the alternate interior are going to be on the inside, interior inside. So opposite inside are going to be angles 4 and 6, and angles 3 and 5. Alternate exterior, again, same thing, opposite sides, but on the outside of my parallel lines. So, for example, angles 1 and 7, and angles 2 and 8. And then corresponding angles, this is usually the trickiest one to remember. Corresponding angles are in the same location at each intersection. So, for example, if you look at the top intersection, we have angle 1 is in the kind of the top left position out of those 4, 1, 2, 3, and 4. And so if you look at the bottom intersection, which other number is at the top left? And that'll be angle 5. So corresponding means they have to be kind of in the same location. So both in the top left, or both in the bottom right, or both in the bottom left, etc. So in this case, our corresponding angles are going to be angles 1 and 5, along with angles 4 and 8, 2 and 6, and angle 3 and 7. Okay, then we have some theorems that eventually tell us this, and we'll go through some proofs of those later on next week. But essentially, if you can tell those lines are parallel, okay, whether that the diagram says that they're parallel, remember though that happens with the little arrows that you see on them, or if the problem simply says these lines are parallel. Okay, if you know that those lines are parallel, then you can say that each of these types of pairs of angles, those relationships, are going to be either supplementary or congruent. And that's going to help out a lot in terms of figuring out different angle measures for all of them. You can kind of use those relationships to jump around and use those to help you find other angles. So first of all, a linear pair, okay, doesn't necessarily deal with a set of parallel lines, but it's still important to include that because a linear pair does add up to 180, so we include that with our supplementary group. And then both of our pairs of same sides. Okay, the way I like to remember this is that the same side angles are supplementary. You're going to hate me for that when you hear this. I apologize, but again, that's kind of the way I like to remember that. And then we have some groups that are congruent. And one of those is the vertical angle pairs. And again, not necessarily dealing with parallel lines, but also congruent. So we want to make sure that we include those in our group. And the way I remember that is the vertical angles are congruent. Again, you're going to hate me. I'm sorry for the consonants, but it works. And then we also have corresponding angles. Again, if you want to use that hard C, corresponding, congruent. Again, that kind of helps. And I'm sorry I don't have any nice fun little trick to help you remember the other two, but your alternate interior angles and your alternate exterior angles are also congruent. And so if you can remember those relationships, if you know those relationships, it's going to make your life so much easier. And so if you need to go back and spend some time doing that, please go. But those are the relationships. And so if you know and you need to remember that which ones are congruent and which ones are supplementary, and what does that mean? Okay, if it means they're congruent, that means they're the same. If they're supplementary, that means they add up to 180 degrees. Now, on the back side, okay, example 1 It says use the diagram below to find the missing angle measures. Again, I'm going to ask that you pause the video right now, see what you can do, try it for yourself, and see how many of these you can get on your own before continuing on. So I'm going to give you about 2 seconds here to pause the video. And now I will show you the answer. And so you'll notice that box right here in the middle means that that angle, CFD, has to be 90 degrees. Therefore, AFB, this small angle right in here, we notice that that angle with the 50-degree angle and the 90-degree angle make a full 180 because they make a straight line. If I go all the way over the top here, that's 180 degrees. So if I add up the other two and subtract that from 180, you will get your AFB. And so in that case, 90 plus 50 is 140. So therefore, the last little bit here must be 40 degrees. CFD, again, just by the diagram, we said was 90 degrees because of that little square in there. Angle DFE, we can see is a vertical angle with AFB. And since those are vertical, we know they are congruent, meaning they're the same. So we have 40 degrees. And AFE is a vertical angle with the top two, the 50-degree and the 90-degree angle combined. Or, again, if you want to think of it as a straight angle with the 40-degree angle to the right, that's a linear pair. So if you add those two up, it has to equal 180. Therefore, that has to be 140 degrees. Okay, so that's kind of what we're talking about here. If you recognize those relationships, you can use those relationships to say that those angle measures are what they are. Then we move on to example 2. Now we're working with a set of parallel lines cut by a transversal. And again, I know they're parallel because of the diagram. Our little arrow markings here tell us that they're parallel. And so again, the example says if angle 1 is 68 degrees, so we know that that top left angle was 68 degrees, determine the rest of them. So I'm going to go ahead and again ask that you pause this for a second, see if you can try it, and see what you can come up with, and then I will give you the answers in just a second. Okay, so angle 1 is 68, and that means that angle 3 must also be 68 degrees because those are vertical angles. And angle 2 is a linear pair with angle 1, and so since a linear pair adds up to 180, 180 minus 68 is 112 degrees. So angle 2 must be 112. Since angle 2 is a vertical angle with 4, it's also going to be 112. Angles 4 and 6 are alternate interior angles, which means those are congruent. So angle 6 is also 112. And 3 and 5 are congruent because they are the same type of pair, alternate interior. So 5 must be 68 degrees. And then again, vertical angles, so 5 and 7 are the same, so that would be 68 degrees there, and 6 and 8, so 112. Okay, and again, that's why I'm saying if you kind of know those relationships, it can make your life so much easier when you're jumping around trying to solve that. Okay. Example 3, lines M and N are parallel. If angle 1 equals 12x minus 4 and angle 5 equals 8x plus 32, determine the rest of the angle measures. So again, I'm going to give you a couple seconds to hit pause on this, try it, see what you can find, and then go ahead and play to see how you did. So the problem tells us that angle 1 is 12x minus 4. Angle 5 is 8x plus 32. And so angles 1 and 5 are corresponding angles. They're both, in the way these are situated, in the kind of top left of their own little intersection there. So since they are corresponding, that means they are congruent. So 12x minus 4 has to equal 8x plus 32. Solving for x, we're going to subtract 8x from both sides. So 4x minus 4 equals 32. Add 4 to both sides. So 4x equals 36. Divide by 4. And x equals 9. So now we're going to substitute that back in. We only have to pick one of them since we know that they're both the same. So I'm going to pick 12x minus 4. So 12 times 9 would be 108 minus 4, or 104 degrees. So angles 1 and 5 are both 104 degrees. And then that means that angle 4 and 8 are also 104 because those are vertical angles. And then now we just have to find one of the linear pairs so that we can figure out the rest of these using our relationships. So 180 minus 104 is 76 degrees. So angle 2 must be 76, angle 3 must be 76, as well as 6 and 7. Okay, so again, we use that relationship, those corresponding angles being congruent, set those equal to each other since they have to be the same, solved for x, substituted that back into one of our expressions, and then found the linear pair to find the other angle measure there. Example 4, last one. In the diagram, roads A and B are parallel. So we have road A here and B. So those roads are parallel. Explain how to find the measure of angle WUV, then find it. So we have this angle WUV right in here. We're also given some information over here on the left-hand side. So I want you to think about this, and again, I want you to write a sentence explaining how to find it, and then go ahead and solve it that way. Okay, so I want you to take a couple seconds and go ahead and pause this video now and try that explanation, and I'll give you a few seconds before I start my own. So if you notice, we had that 9x degrees off to the side here, and those two angles are what we call same side exterior, meaning that they are supplementary, same side supplementary. Again, you're welcome. You're all going to hate me, and that's fine. I'm okay with that. So therefore, those two angles, 9x plus 22x plus 25, has to equal 180 degrees. Because angle WUV and PRS are same side exterior angles, which means they are supplementary. And so now we're going to solve that equation so that we can actually find out what that angle is. So if we combine like terms, 9x plus 22x is 31x plus 25 equals 180 degrees. Subtract 25 from both sides, and 31x equals 155, 31x degrees. Divide by 31, divide by 31, and so therefore x equals 5. So again, my problem didn't ask me to solve for x, right? I needed to do that, but it didn't ask me to solve for x. It wants to know what the angle measure is. So now I have to substitute that back in for my WUV angle, that 22x plus 25. So 22 times 5 plus 25. 22 times 5 is 110 plus 25 will give us 135 degrees. Angle WUV. All right. So that's, again, just kind of an intro to our first unit. Most of that is hopefully review, just kind of a refresher from last semester back in Math 1. If you have any questions, please make sure to just let me know. Otherwise, you guys should be good to go.